Hello students, so now I am back with the chemistry topic which is the increasing and decreasing order, that is arrangement of the elements according to the instructions given below, which will be particularly from the first chapter, that is the periodic properties and variations. Okay, so in this chapter basically we are discussing about 6 periodic properties which include atomic size, metallic character, non-metallic character, ionization potential, electron affinity and electron negativity. Okay, so based on the trend of these properties in groups and periods, you will be asked to arrange the metals or the elements of a given period or a group according to the instructions which will be provided in the bracket. Okay, so you should be knowing about the variation, the concepts, the trend of all these periodic properties across a group as well as across a period as well as down a group. Okay, so let's quickly revise it first. After that we will proceed solving the question. So there are basically 6 properties, out of which we will be discussing very few. Okay, so first one is atomic size. Atomic size, the factors which determine the atomic size are the number of shells, number of shells and the nuclear charge. Okay, one thing which you need to know is as one move down a group, okay, as one move down a group, you should be knowing that the number of shells increases by 1. Okay, so this is basically the group. On moving down a group, the number of shells increases by 1. Okay, from that very concept itself, you can get to know that the size of an atom increases on moving down a group. Okay, since the number of shells increases by 1, the size of an atom increases, or the size of elements increases as you move down the group. Okay, on the other hand, across a period, the number of shells remains the same, but the effective nuclear charge increases. As one go across a period, the effective nuclear charge increases. So when the nuclear charge increases, the outermost electrons are more closely attracted towards the nucleus, thereby bringing the outermost shell closer to the nucleus, which will cause a decrease in the size of the atomic size. Okay, so here as one move across a period, the size of the atom keeps on decreasing. Okay, the reason is that although the number of shells remains constant, the nuclear charge exerted by the force exerted by the nucleus on the outermost electrons will be increasing, which indeed causes the outermost shell to come closer to the nucleus, thereby decreasing the size of the atom. Okay, so this is the key concept. Across a period, the atomic size decreases, and down a group, the atomic size increases. The reason for the increase and corresponding decrease and increase is that across a period, the nuclear charge increases. Okay, thereby bringing the outermost shell closer to the nucleus, causing a shrinkage in the size. On the other hand, as we move down a group, the number of shells increases by 1, which overcome the nuclear forces. So the outermost electrons are free and they are far apart from the nucleus, thereby causing an increase in the size of the atom. Okay, now the next property is the electropositivity or the metallic character. So when do we say that an element is metal? If it has a tendency to lose the electron more easily, then it is called as a metal, and the characteristic is called as a electropositivity. Okay, since as one move down a group, we have already discussed that as we move down a group, the effective nuclear charge decreases. Okay, so the electrons are not closely bound to the nucleus, that is the distance between the nucleus and the outermost electron decreases, thereby resulting in a weak force of attraction of the nucleus on the outermost electron. Therefore, the element can easily donate the lone pair of electron, or the element can easily donate its valence electron, thereby increasing its metallic character. Okay, therefore, on going down a group, the metallic character increases, because the reason is that the size of an atom increases. As a result, moreover, the nuclear charge keeps on decreasing, so the effective pull of the nucleus on the outermost electrons is feeble. So the atom can more easily donate the electrons. As a result, it increases the metallic character. On the other hand, when we move across a period, the effective nuclear charge increases, right? The effective nuclear charge increases, which means that the outermost electrons, so the valence electron, are more closely bound to the nucleus, which makes it difficult for the atom to lose them completely at once. So the metallic character keeps on decreasing. So across a period, the metallic character decreases, and down a group, the metallic character increases. The reverse is a case of non-metallic character. What is meant by this non-metallic character? An atom is said to be non-metallic if it has a tendency to gain the electron or attract the electrons easily. Down a group, the nuclear charge decreases, so the tendency of the nucleus to attract the electron towards itself keeps on decreasing. As a result, the non-metallic character decreases. Whereas across a period, the nuclear charge increases, as a result of which the electrons will experience a more or a greater force of attraction by the nucleus, as a result of which the element tend to attract nucleus more easily, electrons more easily, thereby increasing its non-metallic character. Okay, and next one is the ionization potential or ionization enthalpy. Ionization potential means the minimum amount of energy that has to be supplied to remove a most loosely bounded electron from the outermost shell. Okay, that is, it's the energy we have to supply from outside in order to remove a valence electron from the atom. Okay, we have already discussed that on moving down a group, the size of an atom increases, as a result of which effective nuclear charge decreases. That is, the net force exerted by the nucleus on the outermost electrons are weak. So even by applying comparatively a lesser amount of energy, we can remove the outermost electrons, which means that we have to supply only a minimum amount of energy or comparatively lower amount of energy, which means that down a group the ionization potential decreases. Whereas across a period we have discussed that the effective nuclear charge increases, as a result of which electrons are most closely bounded or rather firmly attracted by the nucleus. So it is much difficult for us to remove the totally bounded electrons from the outermost shell. So we have to supply a greater amount of energy in order to remove the outermost electron from the nucleus. Therefore, across a period, the ionization potential increases, and down a group, the ionization potential keeps on decreasing. Okay, so this very concept you should be having in your mind before solving the increasing and decreasing order. Okay, so now let's solve the questions. So the first question is, we have to arrange the elementary given elements in the increasing order of electronegativity. The elements are lithium, fluorine, and nitrogen. So first of all, you should be knowing you should have a vague idea about the positions of these elements, which are specified in your syllabus, and their position in the periodic table. Okay, so let's discuss it. So the elements are lithium, nitrogen, and fluorine. Okay, so let's see. Let's look at them. These the position of elements. So here is the lithium, here is the nitrogen, and here is the fluorine. So it is understood clearly that these belong to the group 2. Sorry, period 2 of the periodic table. So we have discussed that as we move across a period, the electronegativity increases because the net nuclear charge increases, as a result of which the nucleus will try to attract the incoming electrons. So here the leftmost element, which is the lithium, will be having the least nuclear force, and fluorine will be having the most nuclear force. So the increasing order in this case will be lithium less than nitrogen less than fluorine. So here the correct answer will be lithium less than nitrogen less than fluorine. Okay, the reason is that across a period the electronegativity increases due to the increase in effective nuclear charge. Okay, now the next question, we have to arrange sodium, aluminum, and chlorine in increasing order of ionization potential. Sodium, aluminum, and chlorine. So let's mark this. This is sodium, this is aluminum, and this is chlorine. Again, these are the elements from the period 3 of the periodic table. Okay, so we know that across a period the ionization potential increases because the nuclear charge increases and greater is the nuclear force of attraction on the outermost electrons, as a result of which we have to supply a greater amount of energy to remove the outermost electrons, isn't it? So here the correct order will be sodium. We have to write this in increasing order. So it is sodium less than aluminum less than chlorine. Okay, it will be sodium less than aluminum less than chlorine. Okay, now the next question, bromine, fluorine, and chlorine in the decreasing order of atomic size. Okay, bromine. So let's mark this: bromine, fluorine, and chlorine. Bromine, fluorine, and chlorine in the decreasing order of atomic size. Okay, atomic radius or atomic size. Okay, so here we know that they belong to the group 17, that is the halogen families. Okay, we know that down a group the atomic size increases. Okay, so here the lowermost element in this among the three is bromine. So the size of bromine will be greater. Bromine will be greater than chlorine followed by fluorine. This would be the correct answer. Okay. Now next is, we have to arrange them in the increasing order of metallic character. Okay, increasing order of metallic character. So let's mark these elements in the periodic table. They are cesium and sodium, now lithium, potassium, and rubidium. Okay, these are the elements. So we have to arrange them in the increasing order metallic character. So now they belong to group 1. We know that down a group the metallic character goes on increasing. Okay, so the lowermost element is cesium, which will be of highly metallic, and the first element lithium will be the least metallic. Least metallic element is lithium, and the highest metallic element is cesium. So we have to arrange them in increasing order, which will be lithium less than sodium less than potassium less than rubidium less than cesium. This will be the increasing order of their metallic character. Okay, now the next one is we have to arrange magnesium, chlorine, sodium, silicon and sulfur in decreasing order of atomic size. Okay, so let's mark them. They include magnesium, chlorine, sodium, sulfur and silicon. So now we get to know that they are the period 3 elements. We know that the atomic size decreases on moving across the period. Okay, so the element with the highest atomic size will be sodium, followed by magnesium, then silicon, sulfur and chlorine. So the correct decreasing order will be sodium, followed by sodium will be greater than magnesium will be greater than silicon will be greater than phosphorus will be greater than sulfur will be greater than chlorine. Okay, now the next one is sodium, potassium, chlorine, silicon and sulfur in increasing order of ionization potential. Okay, so let's mark them. Sodium, potassium, chlorine, sulfur and silicon. Okay, so we need to arrange them in increasing order of ionization potential. Okay, so when we look, except all the other elements, the potassium belongs to the group 4. Okay, we know that as one move down a group, the ionization potential decreases. Okay, so among all the other elements marked here, potassium will be having the least ionization potential because it lies in a period just below the other elements. So potassium will be having the least ionization potential, followed by, after which is sodium, after which is silicon, after which is sulfur and after which is chlorine, because we know that down a group the ionization potential decreases and across the period the ionization potential increases. Since potassium lies below all the other elements, it will be having the least ionization potential. Then since sodium lies above it, it will have a more ionization value than potassium. Since all the elements lies left of sodium, the other elements will be having a higher ionization potential compared to sodium. Okay, now we have to arrange chlorine, fluorine, bromine, iodine in increasing order of electron affinity. Electron affinity means the tendency to attract shared pair of electron towards itself in a molecule. Okay, so we have to arrange them in increasing order. So here the correct order will be iodine, followed by bromine, followed by fluorine and then is chlorine. Okay, because down a group the electronegativity decreases. Down a group the electronegativity decreases. If you make a close reference to this, iodine lies below all of the other elements, so it will be having the least electron affinity, while fluorine lies at the top, which will be having the great electron affinity. Okay, but an exceptional case is obtained with respect to the fluorine and chlorine. It is observed that the electron affinity of chlorine will be much greater than fluorine. So this is an exceptional case which you have to note. So the correct order here will be iodine less than bromine less than fluorine. After fluorine is chlorine. This is an exceptional case, okay, which you have to note in particular. I hope this video has been clear to you, and wishing you all the best for your chemistry exam. Do attend it well. Thank you.